Hello viewers, welcome back to Math in Motion. Today, as we promised, that we shall be talking about methods of talk about the method of least squares. This method is used to fit a model. We shall always use it to fit a simple linear model. But remember, in our previous video, we saw we used this method to fit a model. Also today, let us prove how we get to know that our b naught, our intercept in our model. Remember, our model is yi equal to b naught plus beta 1 x1 xi plus the error term. Now remember, in the previous video we used these formulas, but we didn't know where we got them from. But now we say that our beta naught, our intercept, yes, b naught is the same as having y bar minus bi, sorry, b1 times x, yes, b1 times x, and then the b1 is the slope of xi, and then this is the error term, and then you say that our slope b1 is the same as having summation of xi minus x bar times yi minus y bar over summation of xi minus x bar squared. But remember, we also saw that this is the same thing as having summation. Why you recall, we said ki yi, and then we just summarized everything, this thing into this one, and then so this is, remember, we said the ki the same as having xi over summation of xi squared, and then we said that this is the same as having xi minus x bar over summation of xi minus x bar all squared. And then if you just put it back here, we shall have our formula of bi. But today I want us to prove on how we reached these formulas. These formulas we used while we are proving, or we are using the least square approach. Now today let us begin with proving that b naught is the same as having y bar minus b1 x bar. Remember, from our formula that our yi, our model, equaling to b naught plus b1 xi plus the error term I. Now here, if we try to make the error term the subject, our error term I is going to be the same as having now yi minus then b naught then minus then b1 xi. These terms are coming this side to become negative like this. Now from here, since we're saying that it is the least square, we shall square this term and then get its least value. We get its least value by differentiating and then equating it to 0. Now if I square this both sides, I will just square like this. I put a square, this side also, and then, but remember, if I want to get these error terms, I remember many I means that there are many terms. I have term 1, I have the error term when x is 1, I will have the error term for 1. When x2, I have the error term 2. Therefore, I have to put a summation this side. Summation. Okay, let me write it on the new line, not confuse you. I'm saying these error terms are many. Therefore, I'll just put a summation. I'll have to summate all error terms, but squared, equaling to the summation also. If I put the summation, I also put a summation this side. Yi minus b naught minus b1 xi, everything squared. Now from this side here, since we want to get the least square, so the least square of the error term, I'm going to differentiate the square term of the error with respect to b naught and then with respect to b1. So as I get our value of b naught and then the value of b1. Now from here, if I differentiate, if I say d, the error term, the summation of our error term I squared, I'm differentiating with respect to d of the beta naught now here, the first differentiate with respect to beta naught. Then I equate it to 0. Now from this thing here, I will say that if I differentiate with respect to beta naught from our equation here, the same thing as having, I'm differentiating with respect to beta naught. Since I have no beta naught here, it's going to be 0. This is a constant, it's going to be 0. I have a negative, I have beta naught here, it's going to be negative 1, then it's going to be 0. Therefore, I'm going to remain with something like, I'm differentiating. This is the same thing as having negative 1 because of beta naught here, then times the whole of this bracket power 1, then times summation of yi minus b naught minus b1 xi, everything, then power 1. Remember, we drop the power, sorry, I drop the power, I want to drop the power, so it should be negative 2. I differentiate the bracket, I have negative 1. Okay, it has go back again. I'm saying that we are dropping the power, it comes 2, yes. Now I differentiate the bracket, I'm going to remain with negative 1 here, I put a negative here outside. Are we together? Now I already bracket to reduced power, which is going to be power 1, like here, as I've done here. But now I equate to 0. For me, I equate to 0 because I'm saying I want to get the least value. Now from here, I just know that automatically these 2 will cancel with the 2, because divide by 2 so it will be 0. I want to remain with negative outside here. Now if I open brackets here, I have negative summation of yi. Then summation also comes to this one minus, but this negative makes it a positive, plus summation of b naught. Then this negative also comes a positive, plus summation, okay, b1 is going to be, because this b1 is a constant, then summation of xi equal to 0. Now from this step, I'm seeing that these things that have positive, this negative can just go this side, becomes a positive, and then these ones remain this side. I'm saying this is the same thing as having summation of yi, like this summation of yi equaling to, now these ones I have remained this side, this one I have gone this side. I'll have summation of beta naught, yes, plus summation of, okay, beta 1, summation of xi, like that. What are we together? I think let me write it properly with a good handwriting so as we're not lost. I'm saying that this is some summation of beta naught plus summation of, here I have beta 1, summation of xi. Just from here. Now from that step there, recall that for me to have the mean of y, remember our mean of y by is the same as having summation of yi over n. Therefore, for me to have summation of y, this is just the same thing of having our summation of yi, the same thing as having n y bar. Are we together? Yes. Now also, you know that our mean x bar is the same thing as having summation of xi over n, and then it's the same thing as having summation. Therefore, summation of xi alone is the same as having n times x bar. Now, if I fit them back here, I'll have n y bar. I'm putting them back in this equation up here. Where there is summation of yi, I want to put that n y bar. Yes. Then also here I'll have, remember now this is just b naught. Remember I'm summating from 1 equals to 0 up to n. Therefore, I said if I'm summating for any constant, just multiply times the constant, n times the constant I have b naught now plus b1, then n x bar. Now from this step here, I'm seeing that n is constant. N is constant everywhere. Yes, I'm saying that n is everywhere. I just divide by n. If I divide by n, this I have now y bar equaling to b naught. Now plus b1 x bar. The n has, these n's have gone. Therefore, from this step, I just say that b naught is going to be the same as having y bar minus b1 xn x bar from this side. Now this is where we got our formula from. We used to estimate our b naught, our intercept. This is the working we go through to prove that beta naught is the same as having y bar minus b1 x bar. I think the steps are clear. Now let us prove how we arrived at our b1 is the same thing as having this one. Summation of xi minus x bar times yi minus y bar into xi minus x bar all squared. Let us see how we arrive there now. Since we've got our b naught, then we can also get our b1. These are the formulas we used in the previous video. I think you recall. Now let us see how we get b1. I think I can put off this. Yes. Now, me putting off this will help me have space for our, remember, as we said that our error term I is the same as having yi minus b naught minus b1 x1, just making the error term the subject. But remember, I have to square it. Then I square it again. But now I have with the summation of all error terms squared, the same as having summation of all yi minus b naught minus b1 xi. Everything is squared. Now, I want to now differentiate with respect to now b1, because I want to get b1. Now, if I differentiate with respect to b1, I will be having, if I am differentiating with respect to b1, I'm differentiating the error term squared with respect to b1. Now I equate to 0. from this statement, I will have, I drop the power, I will have 2. I differentiate the bracket. When I'm differentiating the bracket, remember I have yi b naught, this one becomes 0 because they're constants. Now I have b1 xi, therefore I will have negative xi, but xi, since it is changing, I'll just have summation of xi, yes, summation of xi, then times the bracket, the original bracket, which was, okay, yes, the original bracket, which was yi minus b naught, minus b1 xi, but everything now power 1 because I'm differentiating, but after equal to 0. Yes, now from this step here, you are saying that this 2 will go, because if I divide by 2, I divide by 2 everywhere, this 2 will go. Now I want to open brackets with this negative. I have now negative summation of xi times yi. Yes, from here, this 2 has gone with a 0. Then I'll have now this negative and this becomes a positive plus summation of now b naught xi, like that. Now this one times this one is going to be plus, now because this b1 is a constant, I have b1 outside, now summation of xi squared, because xi times xi is going to be xi squared. I equate it to 0. Yes, yes. Now from here, I think I can easily, get out my terms out, like for here. Okay, let me just first simplify it to make it. If I bring this one on this side here, this one outside this side, I'll have something like, anyway. Okay, let us. Okay, let us first leave out this step I've done here. Let us first ignore this step I've done here. Since we know the value of b1, since we know the value of b naught, just put your b naught at the start here. Okay, I'm saying this 2 will go. I'll have something like summation of xi, yes, into yi, minus b naught minus b1 xi, like this, equal to 0. Now remember, I know the value of b naught is this one, y bar minus b1 x bar. Therefore, this is just having same thing as having summation of xi into yi minus, now b naught is going to be y bar minus, then becomes a plus because of this minus, now plus b1 x bar like that, then minus b1 xi, just like that, equal to 0. Now from there, I think if I try to open brackets, from here, I'll have something like negative, this negative room in here, then summation of now xi times yi, I have xi yi. Now xi times y bar, I'll have minus xi y bar. Then xi times b, this one I'll have because of it's the plus xi b1 x bar, like that. Now this one times this one I'll have now minus xi squared, now b1, everything going to 0. I will wait on that step also. Now from this step here, you see, I can easily factorize out thing. I have now summation of x of summation of, now here I'm seeing xi is common here. I can say xi out now into yi minus y bar. Are you seeing these first 2 things? I have this one now plus also here I'm seeing xi is common into, now so to be what? Here I'm going to remain with, okay, xi and bi are common. Xi and b1 are common, eh? Yes. Then here I'm going to remain with what? Here I'm going to remain with x bar minus xi, just like that. Everything going to 0. Now, if I try to give each summation, I'll have that this is the same as having the negative summation of xi into yi minus y bar, like that. Now, negative minus, is it? Yes, this negative, yes. But now, I don't put this, okay, negative, let me do it like this, summation of now xi bi b1 into x bar minus xi equal to 0. Now allow me put, since this b1 is a constant, I put it outside, and then this negative enter inside into these brackets, so to become, let's make this one to be positive. I'm saying that this is the same thing as having summation of xi into yi minus y bar. Now I want to take this negative inside here into these brackets. I'll have now plus, but this b1 is a constant, b1 will remain outside. Now summation of now xi into, if I put this one negative inside here, I have negative x bar plus xi. This is the same as having xi minus x bar, like that, equal to 0. Now from this step, I can take this on the other side and then leave it this side. I have now b1 summation of xi. I have b1 xi like this into xi minus x bar like this, equaling to, now this one comes this side, it becomes a positive summation now xi into yi minus y bar. Are we together? But remember, we said that in the previous video, we said that our xi is the same as, for me having xi, the same thing as having capital Xi minus x bar. I think because what we had last time. Therefore, where I have this one, I just put that, I just replace it with xi minus x bar here. Therefore, let me create space by just removing this here. Now, for this step, I'm going to just say that b1 is the same thing as having summation of now xi minus x bar times xi minus x bar, like that, equaling to now summation of now, when is xi, I put there xi minus x bar now times yi minus y bar, like that. Now, if I make my b1 the subject, I'm going to just have the same thing as having, just divide everywhere by this one. I have summation of xi minus x bar, like that, into yi minus y bar, like that, over summation of now, this is going to be xi squared, xi minus x bar, everything squared. And then this was our original formula we had of bi. Therefore, if you ask to prove the method of least squares when you are solving, when you are fitting a simple linear model, you should be able to know how to prove these different formulas. Thank you for watching. I remain Shaka Anwar, the math tutor. I'm always here to help you understand different math concepts. Just feel free to engage with me. Like, subscribe, share, and comment. Remember, as I never use the comment section for anywhere you are missing out, I'll be able to answer. Thank you for watching.